Hello and welcome to another exciting Blender tutorial. Today we're going to be making Pong using simulation nodes. All right, so I was thinking a while back, it'd be really fun to take geometry nodes and see if I could make Pong, but it didn't work. It couldn't work because there was no way to know what had happened on the previous frame. You could only calculate for the current frame with geometry nodes. But now with Blender 3.6, we've got simulation nodes. One new node that adds one new cool feature, and that feature is we can now analyze the previous frame. I thought this would be a really fun kind of thing to jump into, kind of an intro to simulation nodes. But I've got a fresh project file here, and first thing I'm going to do is just make a basic Pong setup. Now, I also want to give a shout out to CG Matter. I saw his tutorial about making Pong, but this is different. So we aren't using the game engine. This is actually using simulation nodes. First thing I'm going to do is we're going to create the paddles. So I'm just going to scale X, bring this down a little bit, and scale Y, and maybe bring it all down just a little bit. I don't want to get too massive with everything. So let's go for that. We can actually just set, let's see, I'll set 0.05 will be my X, and Y will be 0.5, and the Z will be 0.05. I'll have it match the X. We're not going to be using the Z, but it's kind of good to, keep that in mind. Actually, we'll make the Z tall, so it's kind of more Pong-like. That'll be cool. All right, back to the top view with 7. All right, so this is going to be our human-controlled paddle. So I'll call this human. And Shift X, we'll grab X, we'll move it over there to the side. And this one, we'll grab X over here. And we'll set these at, let's see, I'll put this at -5, and I'll put this at +5. There we go. All right. And this one we will call the F2, we'll call this the AI pad. All right. Great. Now we need to create the upper and lower bounds. So I'm going to go Shift-A, Mesh Cube, grab Y, and scale X, and just bring that out to about here, roughly, let's say. Grab Y, bring it down a little bit. Shift-D and Y, bring this down. Something like this, maybe. Exact. Let's see, we'll go with 2.5. Now we need to label these. We'll call this bottom wall, and we'll call this top wall. What we're going to do is create a cube. This will be where our geometry nodes system lives. And let's just zoom out, make it really small, and we'll just come up here. So we've got lots of room. We're going to switch this from the timeline. Actually, we'll keep the timeline. So I'm going to go to the corner where I've got the little plus symbol. I'll click and drag down. That'll make a new window. And now I can switch this one to the Geometry Nodes editor and click New with that cube selected. We'll call this GeoNodes, just so we know which object is our GeoNodes object. All right, great. Now, we can come in here. We'll call this Pong. And I'm going to unhook the input from the output. We don't need that cube. We're just using it to kind of hold the system. But we are going to want these paddles and stuff. So now what we want to do, we'll take all of these and we're going to go, actually just the mesh. We don't want that light. We can get rid of that light to simplify things. So I'll select all these guys and we're going to go F3, apply, scale. All right. Now back to our geometry nodes objects. We can click the little pin icon here. This will pin the geometry nodes window. So if we select other things, we won't lose this. And what we can do is we're going to come over here. And let's get the pads in. So we'll start with the human pad. And then let's also grab the AI pad. We'll just drag and drop them in. And then we're going to create a point. So we're just going to create a points node. So Shift-A, search for points. And we will drop this down. We'll just count up 1. So we're just going to generate 1 point. I can plug this into the geometry. And I might make the radius a little bit bigger so we can see it. Create the new simulation nodes. So we're going to go Shift-A. And we want to take simulation zone, and we're going to drop this here. Let me grab the set position node, and I'll drop this here. Now, if I set this to 1, right, and I hit play, nothing's happening, right? Because this point is just offset 1 square very simply, right? So that's the old way, right? That's the way things used to work, right? But now, if I take this, you see this little purple area that is in between the simulation nodes. Everything that's within this area is going to be calculated every frame, basically. If I take this point and I do the same thing, plug it in here, we take this, plug it in there. So first off, we'll show you that nothing's happening, staying still. But if I take this set position right here and I hit play, now you can see it zooms off. I can make this like 0.1, so it's moving a little bit slower. So there we go. So now it's changing. continually because we're using the offset, right? If we had just used position, right? If I had gone, let's see, vector, and just insert a vector here and set it to 0.1 and get rid of this, it's not going to do that. It's just going to sit still because this is like a static value. We're just setting the position, but the offset's special because you're offsetting the current position by this. So the current position is constantly changing. So this frame, it takes the current position and then it offsets it by 0.1, right? And then we're done. We leave, we go to the next frame, we come in, take the current position, offset that current position, 0.1. So that's how we move a little bit. So that's why when you're using the offset value, it's animating, right, over time. Cool. So now that you get the concept, let's talk about how to do this. So what we need to do is we need to create a way of testing, is this ball in the space of one of these paddles? And if so, switch the direction, okay? Likewise, we want to test, is it in the space of the boundary on the top and down? If so, we want to switch the direction on the Y. And that's how we're going to get it bouncing around. So let's create that test. We're going to do it first for the human pad. So over here, this one. So I'm going to go ahead and first, we're going to set up a value that's going to be our velocity. So, what is the speed and direction that our little ball is traveling in? So I want to go ahead and instantiate that variable. We're going to create it here. So we're going to use the attribute. So we go Shift-A, attribute, and we want to store named attribute. Now I'll drop this here. This is happening outside of the simulation, okay? So we're just kind of doing this, it's this sort of initialization, right? We're just kind of setting this all up. Then we're going to go into the simulation, do a bunch of stuff for every frame, and then we're done, okay? So I'm going to create something called velocity. Go, just type that in. So this could be called anything. I've just called it velocity, so it's clear. And I want it to be a vector. So a vector of 3 numbers. And let's go ahead and set the initial velocity -0.1. So it's traveling this way, maybe a little bit faster, -0.2. Okay, so how do we use that? Well, now what we're going to do is we want to go attribute and we want to, let's see, what was it? I'm going to go named attribute, vector, okay, because we know it's a vector. We copy the name, so Control-C, Control-V. What we can do is we can put it here. I can pop it into the offset. And now what's going to happen is our point is generated. We create a new attribute called velocity, and we attach it to this point, right? This velocity attribute is a vector of 3 numbers, which happens to be set to -0.200. Then we enter the simulation. We send this thing into the simulation. And so it calculates this frame. It takes the position of the point, right? And then it offsets it by the velocity, which we've already set over here. So -0.2. And then we go out and we start the next frame. We take the current position, we offset it by the variable velocity, which is stored over here. Again, this hasn't changed. So if I hit play, you'll see we're just going to zoom off that way towards the other pad. Okay. Now what we need to do is we need to do our tests. Like, is this thing intersecting this? Is it close to it? So let's get some information about the human pad. I'm going to get rid of the AI pad just for now, just so it's cleaner. Now I want to make this relative. I don't want to use original. Relative basically takes the position of this object and the position of the geometry nodes object, and it looks at where are they in relation to each other. So that's relative. And what we're going to do is we are going to get the attribute statistic node. So go Shift-A, attribute statistic. We'll take the geometry output, we'll plug it into here. And we want to get not a float, but a vector, because we're going to be looking at positions. So we need to tell it what we're going to look for. So we're going to grab the position, and I'll explain this in a second. So I'll just drop this in here. And we are also going to need the position of our other object here, this guy. But let's talk about what's happening with this. So we're taking the geometry of the human pad, and we're going into this node. And what this node is saying is, okay, what attribute do you want to get about this? And I'm saying, I want to grab the position. And it says, okay. And now it's dotted, right? So the reason why this is a dotted line is because it's looping through all the elements of this object that have a position. What are all the elements of this object? The vertexes, right? So each vertex has a position in 3D space. So it's looping through every vertex, and it's giving me the mean, the median, the sum, the min, max of all that information. What I want to do is take the max and the min and split them out and look at them in terms of where they're at, right? We want to take the location of our little point. So I'm going to grab a position node. Okay. Now, why is this position node going to give us this position and not this position? Well, it has to do with the way all these nodes plug into each other. But basically, whenever you have a node that's asking for an attribute, right, it's looking at the geometry input to figure out what this relates to. Okay, so this actually this isn't related to anything yet. So we have to connect it to a system somewhere for it to be able to associate with this position. We'll take this and we are going to go for a math node. And we need a separate XYZ. We're going to need a combine XYZ. And we're going to need a vector math node. We'll just line these up and we will get to them. All right. First thing I want to do is I want to take the, let's just figure out the X plane. All right. So I want to look at what's the maximum. So remember, this way is positive, this way is negative, right? Positive, negative side of the Y. So the vertexes of this cube, right, are the maximum value on the X location will be the ones on this side, right? Because they're the furthest to the right. These are the further to the left, so they have a lower value on the X. If this is a negative spectrum, these are further in the negative than these are. Does that make sense? So back is further back, and yeah. So what we can do is we take the maximum, right? Plug it into here. And this is, you can tell these are vectors because they're purple. So this is going to give us the maximum value on the X, Y, and Z for the entire object. It takes all the points, looks at all of them, and it goes, what's the maximum value? So I can split that out and take this X, right? And what we can do is we can compare that X to the X of our little guy. So I'm going to take another separate. I'll just Shift D and I'll plug the position into this. This is going to figure out that it's relating to this points once we plug all this into here. Okay, that's how that's going to work. So we're going to take the separate XYZ and we want to compare both of these guys. So let's do that. I'm going to grab, let's see, we're going to go compare. And I want to compare the X value here with the X value here, right there. And I'll leave the epsilon like 0.01 maybe. We'll adjust that. This is basically like the error. So it's like you can have a bit of buffer on either end. So like if it moves a bit too fast and it goes past the point that we want to compare and it never quite equals it. So basically, does this position equal the front of the paddle? Then this is going to be a 1. If not, it's going to be a 0. Okay, so what do we do if it's true? What if this ball is in this? Well, what we want to do is we want to reverse the direction. So to get it to reverse, we need to change the velocity. So what we're going to do is we're going to add in, actually we're going to take this store named attribute, we're going to duplicate this and drop it here. And I'll just set this to 0 for now. This is going to rewrite velocity variable. Okay, so we want to rewrite it by changing the direction. So we want to take the current velocity, which is here, and we've offset it here. We want to take this value and then we want to multiply it by something. So what do we want to multiply? We want to take this and say, all right, I'm going to grab a, let's see, a Boolean. No. What do I want? A switch. That's right. Let's grab the switch node. Switch node is really cool. We're going to switch the output. So what is it we're going to output is what you think about with the switch node. And we're going to output a floating point value. And we can take this value here, oops, and we can plug it into the switch. So what's going to happen is when this is a 1, this is considered true. When it's a 0, it's considered false, right? So when it's true, remember, we're at the same, we're within 0.01 of the front of this thing. So while that's true, we want to say, okay, we're going to make that -1. While it's false, we want it to be 1. So why is that? Well, I'm going to go here and make this vector math node a multiply vector math. We'll take the velocity and we are going to grab a combine XYZ node and we'll take this output and we'll plug it into here and then we'll plug this into here. Okay, so what's going on? If this is true, if this is false, right? So if it's anywhere else and it's not less than the front of this thing, so it's somewhere off this way to the right, then this is going to be false. This system's going to produce a 1. So we have 1, 0, 0 as this vector, and we're multiplying our velocity by 1, 0, 0. So what happens when we multiply negative 0.2 by 1? It stays negative 0.2. So basically, whenever this is false, this math is saying keep the velocity the same. Don't change anything. However, as soon as it reaches this front or goes past it, we're going to say it's suddenly true now, and we're going to return a negative 1. So now we have negative 1, 0, 0. Multiplying that by this will make this positive 0.2. So we'll keep the same speed, but we'll just switch the direction on the x. So let's watch that in practice. So we'll take this, and we are going to plug this into here. I'll grab these guys and just move them down. Now, because, think about it, we come in to the simulation, our point is moved by the velocity, so negative 0.2, and then we're calculating all this stuff. We're changing velocity, changing the variable. We don't do anything to the position yet. We exit the sim, we go to the next frame. We come in, and now we apply that new velocity that we calculated in the previous frame. So it moves a little bit. And so this way, because we're doing these two steps, this is the magic that allows this kind of thing to work. So let's see if this works. Hit play, and no, it didn't work. Okay, our epsilon's probably too small. We'll change that to 0.1. Bonk. No, okay. So all right, I realized I made a mistake. I had the wrong names. I thought this was the human one, but it's really the AI one. So I'm going to switch that so it makes sense in my brain. Call this human, and I'll call this one AI. AI, there we go. Okay, so this one, I should switch this to human. So, okay, so now this one is actually that pad. Right, so anyways, we take the position of that pad, and we're checking it. I'll go back to compare. We can do that at epsilon 0.1. And now you should see, bonk, it works. So we can see how far we can take this epsilon. I'm not sure. Yeah, that's too small. If we want to be extra safe, we could like actually use less than. And that's probably what we should do. So let's just switch that. We're going to switch to less than. That way, whenever it passes it from that point on, we're good to go. Okay, cool. Now let's shape this out so that we do the same thing, but for every other side of the object. And then we can use this for all of our objects in one kind of hit. So I'll take these separates, I'll duplicate them down. And we're going to take the minimum this time. Actually, we just need one of these guys. So what we can do with this, we can say, all right, if it's greater than the minimum, so we'll go greater than, and we'll take X again, and we'll take Y again. And now we're checking both of these. So now what we want to do is compare both these and say, look, are both of these true? Because this should only apply when both are true. When one of them is false, then this doesn't work anymore. So let's come here, and we're going to get it's called a Boolean math. I'll drop that down, and now we can compare both of these. And if both are 1 or true, so we set this to and. If you want to get the tooltip, you hover over that, true when both inputs are true. So if both of these are true, so we're less than here and we're greater than here. So that means we're right in between. If that's the case, then we're going to pass this through and flop the direction. Okay, so let's see how that plays. Bonk. Yeah, it's good. Now we want to check the Y as well, because what if the pad moves down? Okay, so to do that, we're going to still use the min-max of the object, and we're going to use the Y. So this time we're going to take our less than, we'll bring this down, and we'll say, okay, let's take the Y position, plug it into here. We'll take the Y, which was this is the maximum. So again, the Y maximum, if it's it to be less than the maximum, which is correct, and greater than the minimum. So again, I'll grab this as the threshold. I'll grab Y as the value. There we go. All right, now what we want to check is, are both of these true? Cool. And now we want to check on top of that, are all of these true together, right? Because they all have to be true for this to work. So we're creating the bounds of the object, and we're asking, hey, is all this stuff within it? So pass this over to the switch. Now play, bonk. Well, if I move it up, you should see it'll just go past it like that. So, all right, so now let's take this whole system right here, Shift D, duplicate, bring it down. Let's swap this for the AI. So I'll take another multiply node, bring this one up, and now it should bounce off of both pads. Bonk and bonk. Yep, perfect. Okay. Bonk, bonk, and then we miss. Okay, cool. Now let's do the walls. So top and bottom. So let's grab all this. Shift D, bring it down. Shift D, bring it down. Let's come in here. We're going to grab the top wall. We're going to grab the bottom wall. And I did name these correctly, didn't I? This is the top. Yep, good. Okay. And with this one, what we want to check is, well, we don't want to check all the same stuff. But what we do here is instead of putting it into the X, we're going to put it in the Y. And we're going to combine those vectors and we're going to add them in. But we need to go back actually and just add, I'll switch this one over to the Y as well. You can see we have the X set to 0, right? And the Z to 0. So when we multiply this one in down the chain, it's going to actually delete our X values, which we don't want. Same with this. This is going to be deleting the Y values, which we don't want. So we can just get around that by putting a 1 there. I'm going to close my window. There are dogs outside going nuts. Should have done that ages ago. Okay. And set the Y to 1. Come over here. We'll set the X to 1. And we can leave Z 0 because we're never doing anything on the set. Cool. All right. Now we just need 2 more multiply nodes, just like this. And then we can grab this one, bring it all the way up, plug it in. And then this one, bring it all the way up and plug it in. And now we should have, well, we won't have anything yet because it doesn't have any Y angle. But if we add a little bit, scope 0.1 on the Y, you can see it shoots off and misses. Should hit, bonk. There we go. These things are, should change it. My angle is too steep. I've got like a pro hit there. All right. Jeez, come on, Chris. 0.03, baby. Bonk. Yeah. Bonk. Bonk. There it is. Now it's working. Bonk. Oh, I missed. Get good at your own game, mate. Here, I can. Anyway, you can see that it's working. You can go out of the bounds a bit. Grab it. Come on. Do it. No. Yes. Oh, our timeline ended. Set that to 1,000. Put that back. One more round. Come on. Best out of 2. It's actually tricky to like click it. So anyways, as you can see, at this point, we can stop here. We've got something fun, single player Pong. As you can see, you really need to set your timeline to be something really long because as soon as it hits the timeline, it's going to reset your game. And, if you've got a tight score and you really want to win. And this in itself is actually kind of a fun game. Like having this like solo single player Pong thing where you can move your paddles anywhere. It's really quite fun. So what are some other things we could do? Well, we could add velocity changes to this. So like the speed of your hit. So like take like the angular velocity of the paddle and use that as a multiplier for the actual Pong ball itself. I'm really distracted. The other thing we do is create an AI. I could actually create an AI for the other paddle. So just taking the paddle and have it constantly move to the, say, the Y position of the ball, but give it a speed. So it can't go faster than that speed. So that way, if you're hitting it with higher velocity, and you can like get it through to go by before the speed catches up. And then you can adjust the difficulty of the AI, basically just adjusting the speed of the paddle. So those are some cool ideas that you can add to this to expand. But I hope this little sort of intro to it is giving you a taste of what you can do in simulation nodes. I know this is not what it's intended for, but it hopefully gives you some idea of what's going on under the hood and how you can use it a little bit for some very cool effects. I'm going to drop this project file at Patreon for the month. So if you'd like to check that out, you can head over there. If you join on the 2nd tier and up, you can get access to this along with a lot of other cool stuff. Every month I put new project files in there. And you can also get the full uncut version of this tutorial where I talk about some extra stuff and go into more detail. So check that out. I probably will try the AI and a couple of things in that. So stay tuned. Anyways, Thanks so much for watching. If you love this video, hit that like button. Don't forget to leave me a comment. Let me know what kind of videos you'd like to see in the future, and subscribe. Makes such a difference, really helping the channel grow. Thanks so much. I'll catch you in the next one. Until then, have a great week. See ya.